Hello, everyone. Welcome to the final lesson of the GFSSM Space City Design Series. Today, we will focus on one of the most crucial aspects of space city design, the design of inhabitable spaces in Space City. As we all know, a space city is ultimately intended to provide a place for humans to live and work. Therefore, creating comfortable, safe, and functional living environments is extremely important for the success of the space city. When designing the living spaces in a space city, we will use a very helpful method called design thinking. Design thinking is a human-centered innovation approach. It's all about deeply understanding the needs of the users and creating effective solutions based on those insights. For example, if we were designing our own ideal living room, we would first need to understand what we like, what makes us feel comfortable, and what our essential needs are. Design thinking includes 5 key steps, and we'll go over each one in detail. Empathize. The first step requires us to deeply understand the needs, desires, pain points, and behavior patterns of the people who will live in the space city. For instance, in a space environment, residents might experience feelings of isolation, so when designing the public spaces, we need to think about how to create opportunities for social interactions and community building. Define. After gathering information in the empathize step, we need to clearly define the problems we need to address in the design of living spaces. For example, how do we make the best use of limited space, ensuring that residents feel comfortable and their needs are met? Ideate. This step is where we brainstorm and generate as many ideas as possible to solve the identified problems. We should think creatively about how to design living units that are not only comfortable, but also make the best use of the space. For example, how can we ensure that the living spaces meet residents' needs for rest, work, and entertainment? Prototype. In this step, we start creating models or simulations of the living spaces, using tools like 3D modeling software or hand-drawn sketches. This helps us visualize the designs and understand how residents would use these spaces in real-life scenarios. Think of it like creating a model of a city in a simulation game on your computer, where you can test out your ideas before they become a reality. Test. Finally, we gather feedback from others on the prototypes, allowing us to evaluate and refine the designs based on real-world responses. Now, the question is, how do we discover what the real needs of the residents are? To help with this, let me introduce an important theory: Maslow's hierarchy of needs. This theory divides human needs into levels, starting with the most basic. At the bottom are physiological needs, things like food, water, warmth, and rest. In a space city, these basic needs will be taken care of by the life support system. Next are safety needs. The space city must have a strong and reliable structure, as well as a comprehensive emergency plan, so residents can feel secure and protected. Above that is social needs, the need to interact with others. For example, social activities in space station, astronauts putting up spring festival couplets together. They sharing experiences or participating in events help them feel less isolated. Just like how we participate in different activities or hang out with friends at school, social activities bring us joy and warmth. For the design goal of the human factor department, we need to design public spaces. Next, we have esteem needs, the need for respect and recognition. Everyone needs private space for personal reflection, relaxation, and self-expression. This is also important when designing private living spaces for space city residents. Finally, at the top of the pyramid is self-actualization, the desire to reach one's full potential and pursue personal growth. For instance, astronauts might pursue hobbies like playing musical instruments, reading, or other activities while in space. These opportunities for self-expression are vital for residents' overall well-being. As we design the space city, we must ensure that we meet these different levels of needs so that residents can lead fulfilling lives even in such a unique environment as space. According to Chapter 4 of the RFP, the primary residents of the space city will be staff, researchers, and visiting spacecraft crew members. When designing living spaces for these groups, we need to consider both their psychological and physiological needs. For example, the staff may need a quiet and comfortable environment for rest, while researchers may need access to convenient workspaces that are close to their rest areas, so they can easily switch between work and relaxation. Visitors will need temporary living spaces that meet their needs for comfort and convenience during their stay. Additionally, all residents will need spaces for social activities and physical exercise. These various needs will divide the Space City's living areas into different functional zones. First, there's the residential area, where people will sleep, rest, and relax. Then, there's the exercise area, since residents will need to stay healthy in the space environment. A dedicated area for physical activities will be essential. There is also the entertainment area, spaces for watching movies, playing games, and relaxing after work. And there will be other public spaces like restaurants, shops, and even small cafes, which will cater to the residents' everyday needs. The final design of these spaces will be shown through a floor plan. Take a look at this residential design example. It includes different types of living units, single rooms and double rooms, so it can meet the varying needs of different residents. There are also supporting facilities such as storage rooms for storing personal items, gardens where residents can enjoy nature, restaurants to provide food, and clinics to ensure the health and safety of the residents. By carefully organizing these functional areas, we can create a well-rounded and efficient living space for the residents. Another important design goal, as stated in the RFP, is to make life more convenient and efficient for the Space City residents. This means we must focus on reducing the amount of manual labor they need to do in their daily routines. Think about it. The residents of the Space City are working on critical missions. They are responsible for scientific research, operations, and maintaining the city. Their energy should be spent on these important tasks, not on everyday physical labor. If they are constantly dealing with chores, like cleaning, moving things, or maintaining equipment, they will feel exhausted, and their overall work efficiency and quality of life will drop. Therefore, we must leverage the power of automation and AI applications to solve this problem. These technologies will allow us to create a living environment that is more comfortable and effortless for the residents. Now, it's your turn to be creative. Design a robot, automated device, wearable device, or AI application that can help reduce the physical labor residents face every day. When designing, keep the human-centered design in mind. Think about the daily physical tasks that residents might have to perform, such as moving items, cleaning, or equipment maintenance, and come up with practical solutions to reduce the time and effort spent on these tasks. Be sure to think out of the box and be innovative. Don't limit yourself to current technology. Imagine what futuristic devices and systems might look like in a space city. While smartwatches and smart glasses are common on Earth, they might not be innovative enough for a space city. We need to think bigger and imagine the possibilities of future technologies. Once you've completed your design, explain clearly how it meets the specific needs of the residents. Include details like the specifications, operating modes, and functions, and don't forget to add a simple diagram to help others easily understand your idea. Now, let's talk about the residential area design in more detail. Comfort is critical for residents. Most people prefer living in spacious, well-lit environments rather than cramped, dark spaces. Just like on Earth, living in a spacious room improves your mood and well-being, and the same principle applies in space. However, space is very expensive in space. We need to find a balance between comfort and cost when designing living areas. We cannot just prioritize spaciousness and comfort without considering cost. Nor can we sacrifice comfort just to save money. This requires thoughtful and clever design techniques. These techniques will enhance comfort without adding significant costs. Here are some specific design techniques. Visual design. By using colors, lighting, and layout, we can create a comfortable, welcoming atmosphere that makes residents feel happier. The Venetian Macau Hotel uses fake ceilings to create a strong sense of space. Multifunctional spaces. A space can serve more than one purpose. For example, using different pathways or creating flexible rooms can adapt to changing needs and make the most out of limited space. Understanding the community size is also key to space design. For example, if the community consists of 300 people, what would it look like? What if it's 30,000 people? A community of 300 might look like a small village, with basic needs met and a few small cafes or shops. But a larger community, such as one with 30,000 people, will need more public services and infrastructure, like cinemas, sports halls, hospitals, schools, and shopping centers. If we are designing a smaller space city, will there be children? Should we design schools? Once you've thought through these questions, remove any unnecessary public services, and your design will be more practical and efficient. Lastly, when designing, collaborate closely with the structural department. The layout of the residential areas and public spaces must match the structural design plans in Chapter 2 of the RFP. For example, if the space city is shaped like a ring, its layout would be a long rectangular space when unfolded. If our residential area has multiple floors, what will the ceiling height be? Does it match the design dimensions in the structural plan? Also, consider the relative positions of the industrial, agricultural, and residential areas and plan for transportation needs. With careful planning, we can create a functional, efficient, and comfortable living environment for residents. Today, we covered important aspects of space city living design, from design thinking to specific design techniques, space layout, and community planning. In previous lessons, we also discussed key elements like the structural department, operation, and maintenance department. That would be great if you apply the methods you've learned to complete the designs for chapters 5 and 6. The ultimate design goal is to create a space city that not only meets all design requirements outlined in the RFP, but also innovative and feasible. That's all for today's class. I look forward to seeing your amazing designs.